Hello! Today we will consider another model from Fischer Technique Intexet line. This model consists of 4 conveyor belts with a milling and drilling station. There are also 2 controllers, master and slave. So let's take a closer look at this model. All processes start from this place. Here we see the first conveyor belt and 2 phototransistors. Next is a pusher with an electric motor. This pusher moves the workpiece to the second conveyor. Another phototransistor is also located here. When the workpiece reaches the phototransistor, the conveyor stops and the milling station is turned on. After that, the workpiece goes to the third conveyor with another phototransistor. There is already a stage with a drilling station. After that, the workpiece goes to the next pusher, which moves it to the last conveyor with the phototransistor. At this stage, all processes are completed. Practical part. As we can see, the main program consists of 5 parts. Let's consider each separately. The first part is a conveyor belt. The program begins with phototransistor I5. The lamps shining on the phototransistors are powered in parallel with the phototransistors. Therefore, we do not use them as separate elements in the program. After the workpiece enters the phototransistor's range, the M2 motor starts moving. The motor moves until the workpiece reaches phototransistor I6. After a second pause, the motor stops. At this point, the subroutine ends. The next subroutine is pusher 1. At the beginning of this subroutine, the pusher itself must be in the initial position. For this, limit switch I7 is used. If the limit switch is not pressed, the motor M1 moves to the right until the switch is pressed. After that, the motor will stop and another process will start. Next we can see a very interesting picture. We have phototransistor I6 and phototransistor C1D. Through 2 operators, the wait for element receives information from these phototransistors. This is necessary in order for our program to work correctly with using several blanks at the same time. When the workpiece reaches the phototransistor I6 and there is nothing on the phototransistor C1D, the motor M2 starts again and the pusher M1 is activated, which moves the workpiece to the conveyor belt. After pressing the limit switch I8, the pusher motor changes the direction of movement. At the same time, the motor of the next conveyor starts moving. When the pusher presses the limit switch I7, the motor M1 stops. Motor M3 still continues to move until the workpiece reaches phototransistor C1D. After that, the M3 motor stops and the algorithm returns to the beginning of this subroutine. The next subroutine is milling. As soon as the workpiece appeared in the area of operation of the phototransistor C1D, the motor of the milling machine starts moving. A pause of 17 seconds in maintained. Of course, this time can be changed. After that, the M4 motor of the milling machine stops. At this stage, the auxiliary controller or master controller is already connected to the work. We see the element wait for with the address I5 and the node EM1. It is EM1 means that we are using a slave controller. In the additional menu, we can choose which controller to use. The default is always IF1. Only after stopping the motor M4, the program switches to the phototransistor I5 with the value of 1, which means that the workpiece has not yet moved to it. So after that, motor M3 of the second conveyor is turned on, and after it motor M3 of conveyor with address M2 but already of the slave controller is turned on. This completes the subroutine. The next two subroutines will be controlled exclusively by the slave controller. The penultimate subroutine is the drilling station. After the workpiece passes the phototransistor I5, the motor M2 will stop. After that, the motor M1 of the drilling station will turn on. The motor will run for 23 seconds and then stop. After that, the motor M2 of the conveyor belt will start moving. This completes this routine. The last subroutine is pusher 2. It is necessary to move the pusher to the initial position. For this, the motor M3 and the phototransistor I6 are used. As soon as the state of the phototransistor I5 changes to 1, after a pause, the pusher motor M3 starts moving and moves the workpiece to the last conveyor belt. At the same time, the M4 motor of the conveyor belt starts moving. As soon as the pusher pressed the limit switch I7, its motor M3 stops. The conveyor motor M4 continues to move until the workpiece reaches the phototransistor I8. After the pause, the conveyor motor M4 stops. The pusher motor M3 changes the direction of movement until the pusher presses the limit switch I6. Then the M3 motor will stop and the subroutine and the entire program will end. So now you can look at the result of this program.